Okay, so welcome to this episode of Code Evolution. This morning I thought, after being really inspired by some really interesting black hole physics that I ran into, watching some really cool, to give credit, some things on Universe Today on YouTube, as well as there was a video that showed up talking about harvesting black holes that I think some people have seen, and basically or farming black holes actually, which basically talks about depending on the size of the black hole will dictate how much energy the black hole puts out. And it's an interesting counterintuitive thing that the smaller the black hole is, the more energy it's putting out, the more actual watts it's emitting. So again, very, very fascinating stuff. So what I'm going to do here is go ahead and we'll bring up some of this interesting math, as well as some of the stuff that I've seen. So let's see here. We'll go ahead and So this is let me do the full screen here. So this is the math that this guy on Wikipedia came up. So if you go and look at this, what I'm looking at here is Hawking radiation. And if we go down to kind of near the bottom, I know it's terrible scrolling here. And also I apologize about the audio, but I'm just kind of doing this pretty impromptu. And so here we are. It's in common units. You can derive the power, of the black hole based upon the mass. So the larger the mass in kilograms of the black hole will dictate how much power. So the more there is, the less power is emitted, which is really fascinating. So, like for example, if you had a 1 kilogram black hole, or in this case, some of the examples that they've given is, I like what he says here. So, for instance, a 1 second lived black hole has a mass of, this much. So it would only, even though this seems really big, right? So let's see, 5. That's basically, 100, like 100 times 100,000. So 228,000 kilograms black hole, which is pretty small. We're talking basically, this is if 200, you could look at it like 228 metric tons, I think is basically how that works, or maybe a little bit less when I think about it. Anyway, it's not that big, and so therefore it will evaporate almost instantaneously, and put out a huge amount of energy in that amount of time. So it's very fascinating how this all works. And so what I kept going here, and then you get more information like, okay, well, how long will it last at a certain mass? And this gives you a way of calculating that as well. So, the bigger it is, obviously, the longer it's going to last, right? And this kind of gives you that function. And then the final function being, depending on the lifespan, you could also invert that and get the mass back, right? Now, eventually what I want to do is actually have a chart. I was thinking, man, it would be cool to have a chart that shows off, as the black hole gets bigger, the energy, or the watts essentially tapers off, right? You can see here there's a watt calculation right there, which is fascinating, right? So you're going to have this at a really tiny size, the initial power, as you can see here, this is the example they give, right, is going to be really, really high. And then as it gets bigger and bigger and bigger, the initial power starts to, it's going to taper off. And you can kind of gain, I'm thinking maybe you can gain from this chart that it actually, it will kind of say, as it grows older, right, it's going to lose mass. And we can kind of like maybe derive in a visualization some way of kind of seeing the progression of a black hole. Nobody's really showing me this, and it's hard to find. at that kind of stage. And I'm not a physicist, and I'm not even a mathematician, okay? But this is just fascinating stuff to me. You know, I find this really cool. So I thought, well, the formulas here are really simple. You've got one that, you know, is in seconds, and then you've got its, you know, more approximated version of it in years. And this is great. So why not just take it and turn it into something that can be used in code? And I thought, well, the best way to do that, you know, is you know, kind of come up with this, maybe some sort of component, right? And in the beginning, I'm thinking, well, what I'm going to do is I'm going to create this repo here and check it into, say, npm, and then I could download the actual calculator code, which could live in its own GitHub. And then therefore, you know, the visualization part could be its own like web application or something like that. And then it wouldn't be isolated to, I didn't want to build it all in once. So let's just kind of get started, and we're going to do this export. Wow, that's really big font. Class black hole for now. Okay. And whoa, it's going to wait here for WebStorm. Yeah, actually, I'm going to, before I click yes, I'm going to do a tsconfig. And I know that you guys, I think on this particular stream, you guys are not seeing some of my dialogues because I'm focusing on it. So I apologize for that. But you know, you'll get the point here in a second. Okay, great. You know, then we got my tsconfig. It got added to Git. Yay, hooray, good stuff. We'll go back to this, and I'm going to say configure. And I'm going to say I want to use, now again, you can't see this, I think, but in the dialog, I'm in the TypeScript section of WebStorm that says enable a TypeScript compiler, and I'm going to use tsconfig and OK. All right, and something about TypeScript compiler. Oh, I do not want to add that. I also need to go into my gitignore here, and this I got the gitignore based on Node. But what I need to do is get the, I need to get the gitignore for IntelliJ or WebStorm. So we're going to switch over to the browser here. I'm going to open up a new tab, and oops, what's all this fun stuff? We're going to search for, let's see here, we'll just go to DuckDuckGo. And what we're going to search for is what's I spacing on here? It's morning time. Let's go back to, oh yeah, we need to get the IntelliJ, or let's see, WebStorm gitignore. Cool. I mean, it's probably no big deal here, but why not? Okay, great. Yeah, yep. That's fine. I mean, you can just put idea, but I kind of like to, let's see here, we gotta switch over. All right, and we're gonna add, there we go. Cool. That'll set us up. All right, no more gitignore. Let's go back to black hole. Yay, we've got some JavaScript. Let's go ahead and allow for that JavaScript to be checked into Git. All right. Okay. So we're off and running. We'll set up a constructor just to get started. What's wrong with you? There we go. And, you know, what are the properties that we need to have here, right? Well, according to the according to what we saw before, right? We're going to need, a second here. we're gonna need a property called mass, right? So let's do get mass. Okay. We could make this even simpler. I'm trying to think of like, do we want to? I'm a little bit favoring on having these be read only for now, but we'll go ahead and get mass, and then we'll have a private mass. Okay. And for now, we'll just return this. Now, if I remember right, in WebStorm, we could, this. Yeah, I think in WebStorm you could do something more like this. We could say, now also the other one is we want lifespan, right? Okay, and for now we're just going to make this a number, right? But I think you can, in WebStorm, oh yeah, ta-da! Whoa, look at all that fun stuff that I think just happened. Yeah, whoa. Yeah, so WebStorm will do cool things like set up your code for you. And in this case, we can get the lifespan like this. And you know, kind of less typing for now. I don't want to worry about the setter. And so mass, lifespan, and then watts, right? So we're going to go, again, watts, number, or well, we should probably call it power. Sorry. And we'll do the hitting Alt Enter and then create getter. Woo. Sweet. Copy that. Okay, so we're kind of set up here, and I'm doing it as a read-only to start because I want to actually have, you know, I don't want to sit there and have the user change one property and then that actually be completely incorrect. I want to be able to say, hey, calculate, and then kind of go from there, you know, like based upon those values. So, you know, the idea would be, let's say in this case, we'll just do it all via statics basically. And the beauty of TypeScript and statics is it's not going to complain about anything. So you can basically say, okay, I've created this somewhat immutable class that, you know, just by using getters, and then I'm going to be like, well, okay, cool. And again, we're keeping it simple. I could use other types of data structures here, but we're just going to go with, you know, straight up numbers for now. And you know, we'll make some. Let's just say like we'll go ahead and put some JS docs that says, you know, mass in kilograms. Okay, you know, making it cool. And we'll say time, or we'll say lifespan in seconds. Oops. Okay, ready for spell check. And we'll also put initial power in watts. All right, pretty cool there. I'm gonna go ahead and just kind of clean this up. All right, awesome. And it's, you know, WebStorm's going to give me some grief about like unused method, but whatever. So now we get into the meat of it, right? So we could say like we need to have a calculator that says, hey, black hole dot, you know, calculate from mass, right? So let's do that. So we're going to say static calculate, or we'll just say black hole from mass, okay? And then, you know, mass number. Awesome, right? And then all we have to do is say, we're going to say var result equals new black hole. All right. Now, what's neat about this is that what we're doing is we're creating these factory methods, essentially, that, you know, again, everything here is private. The other option to do, by the way, this is kind of maybe a little bit overkill. I could actually do instead of worrying about the read-only stuff about this, and because we're using a factory, I could use object.freeze, which, you know, I'm starting to think maybe that's actually the right way to do this. This is kind of just overkill. But part of me is like, well, what if you want to change the mass on something, and see it evolve. Well, that's probably not the way to do it. So let's back up here. Let's actually go ahead and I'm gonna say, yeah, let's do this. Now that I've been thinking about it, and this is why this is a live stream, is just kind of off the cuff. I'm gonna say mass in kilograms. It's gonna be a lot cleaner. All right, and I mean, these are things that you wouldn't have to worry about as much in, say, other languages, because you could put read-only, but we are in effectively JavaScript right now, so let's see how this goes. So we got lifespan. You can just take that away. Woo-hoo. And boom. Uh-oh, there we go, power, okay, cool. And boom, get rid of this up. And if you guys are watching this, you know, later, like after the fact, don't forget YouTube. You can put it on 1.25 speed or whatever, and everything will be fine. Oh, I killed off my mask thing. All right, well, we'll just go like this. Okay, so we have these properties of a black hole now, which are just basically, it's like a model, right? But what we can do, which is cool, is we can say, well, I'm going to create this black hole and I'm going to return it. Eventually, I'm going to return it, right? But what I'm going to return actually is object.freeze, the result. What does that do? If you didn't know about object.freeze, well, so, you know, in other languages, you can define if a property is read-only, and it's nice because you can be like, yeah, this is read-only and don't mess with it, and then it's part of the whole compilation and type assertion. But in JavaScript, you know, for a long time, we didn't have anything like that. Object.freeze, well, you could do read-only properties like we were doing earlier. You could do accessors. But with object.freeze, it can simplify your whole code path, and that you're essentially creating this immutable object. You just can't change it, right? And so by calling object.freeze, it basically locks down that object. And if you try to change any property of that object, then it will throw an exception. Now, how do you undo this? Well, you can't undo it. What you can do is you can copy you can make a copy of it, and then refreeze it later if you wanted to. So that's an interesting point. Let's actually make maybe a function of, you know, let's do a clone function. So we're going to do clone. Okay, why not, right? And then we're going to go, so let's say new var result equals new black hole. You know, sometimes I just like to throw this kind of stuff in, right? So we're going to say result.mass equals this.mass, result.lifespan equals this.lifespan, result.power equals this.power. That way, you know, if you did want to grab the values and play with them, you could, but this is explicit. It's like, yeah, you better know what you're doing. Cool. And, okay, we could even call it like writable clone or something like that, but who cares? That's fine. And then we've got our, okay, we need to keep going. Alright, so we've got our from mass here. Let's take everything out. Everything still looks good. And so how do we do this, right? Like, well, how do we do this math? So from math, if we go to our, let me load up the formulas here real quick. Okay, there we go. And you know, again, this is, ooh, I want it bigger, but I don't want it that much bigger. Or there. There we go. Right. So, you know, I want to be able to put these functions in, right? So, you know, it sucks because they don't have, these are actual images. They don't have the actual formulas. So I need to kind of like paste over the actual, the constants, right? And so let's start with that, right? Let's start with the constants. So we're going to add to our, we're going to add to our code these constants. So the first one we want to do, and you know, constants are interesting because we kind of want to like keep them isolated. But we could definitely go ahead and export them though. We could say export, excuse me, export constant, and we're going to export, what is it, so we're going to say power, you know, like power ratio, whatever. And yeah, we'll just call it, there it is. Yep. Number, and it's going to equal with a 3 point something, and let's find out what that is. Hold on, it's 3.56345. 3.56345. And then times, you know, math.pow, it's 10, you know, 10 to the 32nd. That's big. All right, and so there's that. And we'll go ahead and, just for readability's sake, we'll give this another line here. Sometimes what I like to do is do it like this. So if you've started your export constant, and then actually I think we can do. All right, so in power ratio, now what are the other constants that we've got? Okay, so then we've got this other one here that's the lifespan constant, right? That was like 8 point something. Yeah, so 8.40716. Times math.pow 10, and I think it's negative 17 is this one. Cool. Next up, we've got the other one, which is the inversion of lifespan to mass. So we're going to do, which you would think you just could figure that out with these constants, but just for the sake of the Wikipedia article, we're going to do the same thing. So we're going to say comma, and then the constant's going to be, what is it, say mass ratio. Let's be more specific, I guess. It would be power, you know, power to mass ratio, lifespan to mass ratio, and mass, or I wonder if it's 2, anyway, lifespan. This is more like, this is actually inverted. When you really think about it, it's mass to power ratio. And then mass to lifespan. This is more correct. And then we're going to do lifespan to mass. I think. And then we're going to go equals, and then the number that they have there is 2.28271. 2.2, what was it again? 8271. math pow 10 to, I think it's the 5 is the actual thing here. Yeah, that is the that's for the seconds, yeah, lifespan seconds. Okay, cool. Now we have our constants, and then we can kind of leave them alone. And that way, you know, if we did want to come back and grab these values from somewhere, we've exported them, and hooray, happy. So next up, what we're going to do is simply go in here and say we've got our constants, and for this, we're going to say we've got our mass. And so we're going to say mass to power ratio. It's going to be pretty straightforward. We're going to say result dot mass equals this. And then if we look at our function, the way that they have it is they're multiplying, essentially, I think it's like 1 over the mass. Let me check again. You guys can look at it with me. Transition. Okay, so yeah, we've got our, yep. So they've got it, yeah, basically 1 over m, right, squared, sorry. So we got to go math pow that squared, and then we have our watts. Okay, so 1 over the mass. And then here, to be proper, we're going to go ahead and mass go. Okay. Yay! All right, we've got documentation. Okay, and awesome. Now, like I said, we need to put this in math. Dot pow. Okay, that looks good. Next up, we're gonna do lifespan. Okay, and if we look at lifespan is same kind of thing, except that it's inverted. So obviously the larger the mass, the more, and in this case it's cubed, right? So we're gonna go ahead and say mass to lifespan ratio. And we're going to say to the power of 3, but in this case it's the mass over, right, okay, so it's just the mass, that's it. Let's take a look again. Yeah, I mean, they put the units in, which is great, because then they just cancel out the units, right? So that number times the mass cubed pretty much is it. Great, awesome. And the next up, we're going to do the well, that's, oh, is that it? Oh, sorry, I screwed this up. I need to say mass equals, I'm being pretty silly here. And then we're going to say result.power equals, yeah, well, that's it. Well, cool. All right, because we only need to do 2 functions based upon this. So we set the mass, we calculated the power, and then we calculated the lifespan, and voila, we have our object, and it's frozen, so it's essentially immutable. And if you want to get a new version of it, then you'd have to clone and update those values. So what about from doing other statics though, right? We need to do static from what do we have? From lifespan. That's one that's that is one that's possible, right? So we're going to say lifespan number. Okay. And we're going to do same thing, right? We're going to basically copy this stuff. Yay, going faster now. We're also going to And in this case, we're going to do lifespan is, and we're going to say the same thing. Oops. Right. From its lifespan. So we're going to calculate properties of black hole from its lifespan. Okay. All right, and so with that, what we're trying to do is calculate the mass, right? And so we have to say, according to it, we're gonna, well, obviously we're gonna set the lifespan first, right? That's kind of logical. Okay. I wonder if I could probably just hide this for now. That would be a little bit better. We don't need to see the file structure anymore. And then we're going to say is, okay, from result lifespan, now we need to calculate the mass, and then we'll be able to calculate the power, right? So let's go ahead and just for, to make it easier, right, because we're calculating the power based upon the mass, right? So we're going to go let mass equals, right? And then we'll have our function. And so then we're going to go mass, or sorry, it was, is it lifespan to mass ratio, right, times something. Let's go ahead and look over here at our thing. Oh no, I'm sorry. Did I screw up and not transition back? Oops. This is where we got to, sorry. I didn't transition back over. So I copied this over here. So let's, again, we're going to go back to the last function here, which is this one, and we just need to put this in. Now this one is 1/3. Interesting. So we have to do, 1 divided by 3. It's going to be really interesting. Seconds. So it's lifespan to the 1/3 power. Okay. And let me check here. Yep. All right. Back to the code. Sorry about that. Again, that's the stickiness of live streaming. So to review real quick, what we've got is this is the function we came up with from mass, right? And we've got the thing, we've got the mass, we've got the power, all that stuff, and then we freeze, right? So then we're going to do another static, which is, all right, from lifespan. So same type of thing, we set the lifespan, we're going to go ahead and calculate the mass based upon the lifespan. So we're going to say ratio, and it's math.power lifespan 1/3. Okay, that seems pretty good to me. Let's double check our stuff. Transition. Right. Okay, so this looks pretty good. Yep, there's that ratio. It's lifespan to the 1/3. Seems good. Okay. Go back. Okay, so now we're going to do the last one, which is, I think, what did we get from mass, from lifespan? Oh, I guess there really isn't, right? Like you could do from power, right? But I don't think that's the point, right? You kind of want to be able to say from both of these to get the power that's coming out of it. But I don't see any reason why you couldn't do it from power. All right, let's try. Let's copy this. Okay, like from its power. I believe they call this temperature in the sense of its power. So let's say from power, but power. And if we look, okay. Cool. All right. So now what we're going to do is kind of, I guess, reverse what we did before, which is this function, I think. Is this even possible? Oh, because it's a square root, right? Oh, okay. So we can get the mass. Ah, okay. So here's the power function, right? And so what we're going to say is that we can let, obviously we're going to go result.power equals power, right? And then we're going to do the same thing here where we kind of let the mass equal a certain thing. But we're going to look at our function again, which is this one. And this is how we derive the power. So to invert that, right, we're going to need to divide by, we're going to need to do some algebra, right? So the first thing is we're trying to gather up what the mass is. And so we need to take the power. Let me clear this out here. Power. It needs to be divided by this ratio. Okay. And then also we're gonna divide by both. No, that's not right. So then we've got the power, we've got this equals that, right? So right now we're at this phase. If you looked at algebra, right, it would be, let's say mass power ratio times, times this equals, there we go. Right? That would be the algebra that we're at right now, which means that we just have to square root that, right? So we're going to go math.square root ta-da, sweet. And so now we're at that point. So if we take, go ahead and copy this over again, I'm doing typing. Typing in algebra is probably not as good, but we're doing it. And that equals this. Okay, sweet. We can get rid of that for now, right? Okay. And then we need to invert, right? So now we need to basically put this 1 over, basically multiply times math on both sides, or we need to invert it. So we need to say 1 over, right? I'm going to say mass equals 1 over. That's it. Slick. Okay, cool. And from there, that's it. I think we just did it. So we set the power. We then, from power, we can figure out the mass and set the mass, right? And then from that mass, we can derive, well, we don't want to redo power again, right? But we do want to do lifespan. So let's go up to here. And I think we just did it. Cool. All right. Well, I think that's really all I wanted to do for now. Why is it giving me grief on this? You use method. Well, I don't care. And in fact, we don't care if it's unused either. So I'm actually gonna say suppress and actually, if I'm never really using it, I don't need it. I'm being silly. There's no constructor necessary. Thank you, WebStorm, for checking me and making sure I'm not being dumb. All right. In the meanwhile, this is going to be used. I'm going to suppress, and now we get our happy little green check mark in WebStorm. And we got some cool things here, right? We've basically come up with a structure for this mathematical model. And we get an ability. We typically are going to freeze it. We gave it an option for cloning, and let's see here, and then we give a couple ways of deriving a black hole. We can get it from its mass, we can get it from its lifespan, and I hope I got that right, we can get it from its power. Please, if anybody gets to this point and they want to check my math, please do. I haven't written any tests for this, because this thing it's math, right? So would be rewriting the same code over again. Essentially this needs to be manually tested, via a calculator. And in the meanwhile, what I'm going to try to do is check this in. So let's see here. If we go to view project, and we're back up in here. And here's my code. This is it. I just wanted to expose a class that was accessible, and then I'll probably set up an npm, that can be get it from npm, and then if we use it in another project, and then eventually what we'll have is a block of code that can be reused for visualization. So yeah. Anyway, I hope that's cool. I hope you guys like this video, this stream. I just kind of wanted to do an impromptu thing this morning, and maybe there's something to be learned here. Maybe there's something to learn about how to set up your project. Maybe there's something to learn about how to do documentation, how to set up a model class in TypeScript, whatever value you can get out of this. And again, I apologize for the middle of the video where I lost track of the fact that I wasn't showing up in code, but hopefully I made up for that. So thanks again, and we'll see you next time.